So in the notes, I talked about relating the antiderivative to an area function, where the antiderivative is the area from some fixed point A to some variable point X. So this is a linear function, and we're basically gonna drag this X. If I drag this X left and right, okay, it's gonna change the amount of area. And that's going to give me a function. So as I move X, I get different values of area, and that's going to give me the area function. Okay, so the area underneath that linear function is going to be shown by that shaded area. So if I actually just trace the area, so on this side here, we're going to plot the y values. Okay, so on the right hand side, we're going to plot the y values of the area. So as I move that, so if I go down here, if I let A and X be on the same spot, there's 0 area. So notice the Y value on the right hand graph is 0. Okay, and as I move it to the right, I get more area, and it's just tracing out the area values on the right hand side. Okay, so you can see that's the shape of the area function. Now if I go to the other side, I'm going backwards area. Okay, so I'm actually getting negative area, the opposite area. So above the curve is negative, so you can see that here we're in the negative values of y, and then here they become more positive again. Okay, so these are adding up positive values of y. And if you notice that the area function underneath the linear function is a quadratic function. Okay, that's kind of what we expect, and that's why we can relate the area underneath a linear function to its antiderivative, because the antiderivative of a linear function is this quadratic function here. So this is how we define it. Okay, so this is our area function here. This is a of x. And on the y-axis here, this represents a of x. And you can see that underneath the area underneath the linear function is going to give us a quadratic function. Okay? Or in other words, the area under the linear function is related to the antiderivative of that line.